Now dear student, we are going to discuss question number 10.16, and in this question it is given to you the cylindrical tube of a spray pump has a cross section of 8 cm square, one end of which has 45 holes of each diameter 1 mm. Clear? Listen carefully what is given in a question. Let's suppose I am saying here we have a this tube, clear, and let's suppose we can see this tube is having this cross section, clear, and let's suppose here we are having, let's suppose if we are saying here we are having a very small holes like this, and we total have n equal to 40 number of holes. This is given in a question, clear. So the cylindrical tube of a spray pump has a cross section. It means I can say, let's suppose I am saying this is 1 and this one is 2. So A1 is given to you 8 cm square, okay, one end of which has 45 holes each of diameter 1 mm. So I can say n equal to 40 and I am taking A2. Now important part A2, because diameter is given to you, I can say area of a one hole, this is pi by 4 into d square, diameter is 1 mm, so I can convert into 10 to the power minus 3 whole square. Clear to you? We can also convert this area into also meter square, 10 to the power minus 4 meter square. Clear? Now it is also given if the liquid flow inside tube is 1.5 meter per minute, it means we can see value of V1, this is given to you. So V1, this is given 1.5 meter per minute. First we can convert this into seconds, clear. So I can write like this, 1.5 divided by 60, this is meter per second, clear. Now what is my objective? My objective is clear here, is to first find speed of ejection, clear. Speed of ejection means we have to calculate here value V2, clear. But actually if we find total area at section number 2, I can say this should be multiplied with 40, clear. So now what can we do? We can apply here equation of continuity, clear. So equation of continuity, if I write here, I can say this is given by A1 V1, this should be equal to A2 V2, clear. So A1 value is given 8 into 10 to the power minus 4 multiply, if I am talking about V1 is given to you 1.5 divided by 60, this should be equal to, now if I am saying value of A2, so value of A2 we have pi by 4 into 10 to the power minus 6 multiply 40, and V2 is my objective, clear. So I can say this is V2, clear. Now first of all let us try to cancel some part. This is 15, clear. I can say this is divided by 10, 15 and 15 cancelled out, clear. So we can write like this, 8 into 10 to the power minus 5, this is equal to pi into 4 into 10 to the power minus 5 into V2, clear to you. So now we can say this one we have 2, this is and this cancelled out. So from here we can say V2, this is given by 2 divided by pi, clear. So we can write like this, this is 2 divided by 3.14, clear. So approximately you can take, let's suppose this is 3, clear. So if you write here you can say V2, this is given by 0.67 meter per second. I am just saying this is approximation because we know 2 by 3 equal to 0.6666, clear. So I can say approximately I am taking, or more about this is 0.62 meter per second, clear. So this is all about this question, and this is the velocity through which this liquid is actually come out from each hole, clear. So this is all about this question. Now dear student, we are going to discuss this question number 10.17. In this question it is given to you, we have a U-shaped wire dipped in a soap solution, clear. So let's suppose I am saying here we have this is just a minute, yes. So I am saying here, let's suppose if I am saying this is a U type of a wire, clear, and let's suppose this U type of a wire is actually dipped in a soap solution, clear, and let's suppose here we connected a wire and this wire can slide on this U tube, clear, or we can say this U-shaped wire, fine. A U-shaped wire is dipped in a soap solution and removed, okay. So when this U-shaped wire is removed, definitely we can say here we are getting a layer, or we can say surface of a soap solution like this, clear. Now it is given the thin soap film is between the wire and light slider supports a weight of 1.5 into 10 to the power minus 2 Newton. So it means I can say here, let's suppose here we are connecting a weight. This weight is actually very small because this is a very thin, we can say thin surface, clear. So value of weight, this is given to you 1.5 into 10 to the power minus 2 Newton. This one is given to you, clear. Now which includes small weight of a slider. Fine. The length of slider is given 30 centimeter. So I can say length is given to you L. This is equal to 30 centimeter. Now my question is here is to calculate value of surface tension, clear. So dear student, do you know surface tension is defined as force per unit length, clear. Let's suppose I am taking any container and I am taking top view of that container, and let's suppose if I am drawing here an imaginary line, clear, and that imaginary line is having value L, clear. So definitely we can say a force that is acting perpendicular in both the direction, clear. So force acting per unit length, we have surface tension. So we can write here surface tension is given by F by L, but clear. An important part we have, it is given in a question, we have a soap bubble, or we can say we have a soap solution, not bubble, we can say here we have a soap solution, clear. So whenever we have a soap solution and whenever we are making a frame by using soap solution, so every soap solution is having two layers. Whenever a surface is formed, it is always having two layers, clear. So at the time I can say here, if I am taking here length L, then we will take here twice L, because we can say here we have a two surface of soap, clear. So concept is very simple here, soap surface, or we can say soap surface, just a minute, we can say here soap, yes, soap solution surface, soap solution having two surface, clear. So from here we can say, we can write like this, this is S equal to F by 2L, clear. So from here we can say value of force, force is given to you, this is equal to weight because this is balancing. So I can see in this question, we can say surface tension, for the surface tension force is acting perpendicular to this length in this direction, clear, and we can say this force is balancing this weight, clear. So we can say this magnitude of this force equal to this weight. So value we are getting, this is 1.5 into 10 to the power minus 2 divided by 2 multiply, I can say length L. So L is given to you, yes, 30 centimeter. So this is 30 into 10 to the power minus 2. I can say this one and this one cancelled out, clear. So now we can say this is equal to 3 by 2 into 2, clear, and 1 by 30, clear. So we are getting this value in Newton per meter, clear. So we can also calculate like this, this is 1 by, we can say this is 10 and we have 40, clear to you. So from here you can see we are getting 0.1 by 4 or 0.25, clear, 0.025 Newton per meter, clear. So this is value of surface tension, this is acting between this slider, or we can say between this soap solution, soap surface, clear. So this is all about this question. Now student, we are going to discuss question number 10.18, and in this question it is given to you, we have figure number A, it is showing to you we have a very thin liquid film supporting a small weight 4.5 into 10 to the power minus 2 Newton. Fine. What is the weight supported by a film of same liquid at the same temperature in figure B and C? Now listen carefully. Now we can say, let's suppose this is a U type of a wire. Let's suppose here we have a slider, and let's suppose we dip this U type of wire in a soap solution and we are removing that wire. So at that time you can say here we are getting a soap surface, clear. So we can say this small weight is attaching, and let's suppose this slider is at equilibrium position. It means we can say net force this is acting on this slider is 0, clear. So in this case I can write like this, F. This F is actually given by surface tension multiplied with twice L, because if we are talking about, let's suppose this surface is for soap surface. So for soap surface we have to, we will get here twice length. Why? Because every soap surface is having two surfaces, clear. So now I can say from here you can say F is given by twice SL, means whatever the force this is acting here, it depends only on surface tension as well as length of this slider. Clear to you? So now we can say it means it does not depending on the area of the surface of this soap. Clear? It means we can say for situation B and C we will get the same result. Clear? It means we can say weight supported by a film in case number B and C we will get that is same, and that value will be equal to 4.5 into 10 to the power minus 2 Newton. Clear to you? Yes or no? So this is very simple question. This is all about this question. So student, we are going to discuss question number 10.19, and in this question it is given to you what is the pressure inside the drop of mercury of radius 3 mm at room temperature. Clear? So now first of all you should know here it is given this is drop of mercury. Clear? Drop of mercury is given to you. So radius is given, this is equal to 3 mm. Clear? Or you can say 3 into 10 to the power minus 3 meter at room temperature. Clear? Surface tension of mercury at that temperature, we can say surface tension. So value of S, this is given to you 4.65 into 10 to the power minus 1, this is Newton per meter. This is given to you. Clear? And the atmospheric pressure, it is also given. So pressure, atmospheric pressure, this is given to you 1.01 into 10 to the power 5 Newton per meter square. Clear? Now we have to calculate here number 1 what is absolute pressure inside this drop, as well as we have to provide here what is excess pressure. Clear? So now we know excess pressure formula for a liquid drop, this is given by 2S by R. Clear? Now we can say S is what? This is a value of surface tension. So 4.65 into 10 to the power minus 1 divided by value of R. R is given 3 into 10 to the power minus 3. Clear? So from here we can say this one and this one cancelled out. I can say this is 10 to the power minus 2. Clear? So now we can say this excess pressure is given by 2 into 4.65 and it is divided by 3 into, I can say this is 100. Clear? So now if you divide here, you can say this is 1 point, we have 5 and we can say this is also 5. Clear? So now if you multiply, you can say excess pressure, this is given by 1.5 we have 3 and we can say this is 310. Clear? So I can say this is 3.10 multiplied with 100 and this is 310 Newton per meter square. Clear? So this is the value of excess pressure inside this drop. Clear? So can we calculate here absolute pressure? Yes, absolutely. So we can write here pressure P, this is given by P ATM plus this is rho GH, or you can say this is a gauge pressure. Clear? So directly we can say atmospheric pressure value is given to you 1.01 into 10 to the power 5 plus I can say rho. Clear? So density, because this is a mercury drop, so actually this is what? Gauge pressure. Gauge pressure value we have already calculated, this is 310. Clear? So I can say this value we have 310. Clear? So from here we can write like this 101,000. Yes or no? Yes. Clear? Plus I can say we have this is 310. Clear to you? 1.01 into 10 to the power 5, we can say this is 101,000 plus this one. So from here you can write like this 101,310. Clear? Or you can say we are getting absolute pressure, this is equal to 1.013 into 10 to the power 5 Newton per meter square. Clear to you? So this is all about this question. Clear? Now dear student, we are going to discuss question number 10.20, and in this question actually this is a good question, and in this question it is given to you what is the excess pressure inside a bubble of soap solution. Now very important, here we have a soap bubble. This is very important. Clear? So inside a bubble of soap solution of radius 5 mm. Clear? So value of radius, this is given to you 5 into 10 to the power minus 3 meter. Clear? So this value is given to you. Now given that surface tension of a soap solution, so we can say value of surface tension we have 2.5 into 10 to the power minus 2 Newton per meter. Clear? This is given. Now it means first our objective here is to calculate excess pressure inside soap bubble. So what is this formula? formula we have, this is 4s by r. Clear? Now we can say 4 multiply, this is 2.5 into 10 to the power minus 2 and 5 into 10 to the power minus 3. Clear? From here we can say this one is 2, this one is also 2. So we can say excess pressure, this is given by 2 multiply 10, I can say this is 20 Pascal. Clear? So excess pressure we have 20 Pascal. Clear to you? Yes. Now we can say, now let's suppose we are taking another situation. If an air bubble of same dimension means we can say radius is same, it is formed at a depth of 40 centimeter inside a container. So let's suppose an important containing soap solution. Clear? So now listen carefully. Let's suppose here we have a container. Let's suppose in this container we have a soap solution. Clear? Let's suppose here we are having air bubble. Clear? And it is given this depth we have 40 centimeter. Clear? This is we have 40 centimeter. Clear? So this one. Clear? This one. Clear? So we can say this one we have 40 centimeter. Clear? Now important part is here, can we find here first excess pressure inside this air bubble? Yes, excess pressure inside this air bubble, this is given by 2s by r. Clear? Always keep in mind excess pressure in a liquid drop or excess pressure in an air bubble, this is same, and excess pressure in a soap bubble, this is given by 4s by r. Clear? So now I can write like this delta P here, this is given by 2 multiply, I can say s. Clear? So s value is given 2.5 into 10 to the power minus 2 and it is divided by, this is equal to r. R is given to you 5 into 10 to the power minus 3. Clear? So because we are taking same surface tension, or we can say surface tension is different, no. Clear? So if an air bubble of same dimension, so we can say surface tension value we have this one. Clear to you? Yes. So now we can say from here we are getting value, just a minute, actually we can say pressure, important part we have what is value of this surface tension. Clear? So I can say surface tension value, this is given by, okay, we are taking same. Clear? Now yes, so now if you calculate, we can say this one we have, this is 2 and 2 cancelled out, and from here we can say the excess pressure of this air, this is given by 10 Pascal. Clear to you? Clear? A very simple calculation, we have 4s by r and 2s by r. Clear? Now important part is here, this is excess pressure inside this air bubble. Clear? This is excess pressure inside this air bubble. Now can we calculate here? Clear? Objective is what? Objective is here, our objective, what would be the pressure inside bubble? Clear? So definitely this is a excess pressure, but can we calculate here net pressure? Yes. How can we calculate? Listen carefully. For that one, you can see on the surface of a liquid we are having atmospheric pressure. Clear? And after that we have certain depth 40 centimeter, it means I can say this is equal to rho gh. Clear? Clear? And after that we can write this excess pressure. Clear? Listen carefully. Here we are having atmospheric pressure. Clear? So I am calculating here net pressure. So P, this is given by P ATM plus I can say this is rho GH plus we are having some excess pressure, this is equal to 10 Pascal. So I can say this is plus 10. Clear? Now atmospheric pressure is given 1.01 into 10 to the power 5. 1.01 into 10 to the power 5 plus. Now if I am talking about density, so density of this soap bubble is given, this is relative density 1.20. So it means I can write like this 1.20 into 10 to the power 3. Clear? Value of G I am taking 10 and multiplied with, this is 40 centimeter, it means I can write like this. Clear? Plus 10. Clear? So now we can say 1, 2 and this one is cancelled out. Clear? So now we can see 101,000 plus, if you multiply this 1.20 with 1000, I can say 1200 like this, 1200. Clear? And multiplied with 4 plus 10. Clear? So now we can say final value we are getting 0 0 0 plus 4800 plus 10. Clear? So if you add directly, you can say here we have 0, at the end we have 1, clear, then we have 8, then we can say this is 5 and 1 0, clear. So we can say this is Newton per meter square. So we can say this is net pressure, this is acting inside this air bubble, clear. Here we added first atmospheric pressure, then this is rho gh, then we can say excess pressure inside this air bubble, clear. So this is final answer 1058 10 Newton per meter square, or you can say this is equal to 1.058 into 10 to the power 5 Newton per meter square. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss this question number 10.21. Clear? In this question it is given to you a tank with a square base of area 1 meter square is divided by a vertical partition in the middle. Clear? So now I can say let's suppose I am taking here, this is a tank, clear. Let's suppose I am taking this is a tank, clear, and in this tank we have a square base. So you can assume this base is having a square, and area is also given to you, this is 1 meter square, fine. Now it is divided by a vertical partition in the middle. So let's suppose I am having here this vertical partition, clear. This is a vertical partition I am having, clear, okay. The bottom of a partition has a small hinged door. So let's suppose this is a small hinged door, and this area it is given to you 20 centimeter square. Clear to you? Yes. The tank is filled with water in one compartment. So let's suppose first I am filling water in this compartment. Here we have water, clear. So I can say here we have water, clear, and now it is also given the tank is filled with water in one compartment and an acid in the other, clear. So let's suppose I am saying this side we have acid, clear, acid, fine. Now it is also given both to a height of 4 meter. It means this height, this vertical height is given to you 4 meter, fine. Compute the force necessary to keep the door closed, clear. Now let us try to understand this question. Let's suppose I am actually, you can see here we have a container. In this container we have two partition, and at the one side we have water, another side we have acid, clear, and at the bottom we have a hinged door. And let's suppose if we want to keep this hinged door closed, it means we can say net force acting on this hinged door, it should be 0, clear. So first we can calculate here that force that is exerted by water side, what is force that is exerted by acid side, clear. So for that one first we calculate pressure, clear. So let's suppose I am saying this is part 1 and let's suppose part 2, clear. So first of all I am calculating here pressure due to part number 1, clear. So I can write like this P1, clear, P1, clear. Directly you can say you can take here atmospheric pressure also, yes or no? Yes or no? We can take here atmospheric pressure, yes, or you can also take here gauge pressure. Why? Because atmospheric pressure will come at both sides, clear, definitely it will be cancelled out. So directly I am saying here I am writing this is gauge pressure, this is rho gh, clear. Now if I am talking about water, so this is density of a water and height of a water column, clear. So density of water is given, this is 1000, we know very well. Value of G I am taking, this is 10, and what about the height of water column? Height of water column is given to you 4 meter, clear. So from here we can say, we can write like this, this is 4 multiply 10 to the power 4, clear, and I can say this is Newton per meter square. Same we can calculate value of P2, pressure that is exerted by acid side, clear. You can say here we are having this is P1 and let's suppose we are saying this is P2, clear. So we can say this is density of acid G and height of acid column, clear. Now it is given relative density we have 1.7, so we can say this is 1.7 into 1000 and it is multiplied with G, and height of water or acid both are given, that is same, so I can say this is multiplied with 4, clear. So now we can write like this, this is equal to 4 into 10 to the power 4 into 1.7 Newton per meter square. now if you observe, definitely you can say P2 is greater than P1. Clear? It means we can say pressure that is exerted by acid side, this is more compared to pressure that is exerted by water side. Clear? So now we can see our objective here is to calculate net force. So we can write like this: net force, this is given by P2 minus P1 and multiplied with this area. Clear? So now we can say P2 minus P1. Clear? So P2 we can say we have 4 into 10 to the power 4 into 1.7 and this one. So you can take here 4 into 10 to the power 4 common. Clear? I can write like this: 1.7 minus 1 and multiplied with area. Now we will take here this area of a hinged door. Clear? And area of a hinged door is given to you 20 centimeter square. So I can write like this: this is 20 into 10 to the power minus 4. Clear to everyone? So now we can say this is 4 into 10 to the power 4 multiply 0.7 and we can say 20 into 10 to the power minus 4. Clear? So now I can say here, if you calculate, I am just rubbing here. Clear? Yes. So now from here we can say net force, F net. This F net that is given by 4 into 10 to the power 4 into 0.7 into 20. So if you multiply, I can say this is 80 into 10 to the power 4 into 7 by 10 multiply. Clear? We can say this is, you write here, this is 4 multiply 20, fine, 10 to the power 4, 7 by 10, clear, and we can say this is 10 to the power minus 4. This one and this one cancelled out. Clear? So from here you can say, we can write like this, divide by 10 and this is equal to 56 Newton. Clear? So now we can say net force that is exerted on this hinged wall, this is equal to 56 Newton. Clear? And definitely this force is actually more from this acid side. Definitely we can say at this time this hinge door will not be closed because force exerted will be more by the acid side. Now what we can do? Actually if we apply same force from water side, at that time we can say this hinge door will be closed. Clear? So now we can say force exerted by water side to keep hinged door closed. Clear? So I can say this is equal to what? This is equal to 56 Newton. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss question number 10.22, and in this question it is given to you a manometer reads the pressure of a gas in an enclosure as shown in figure A. Clear? So now when a pump removes some of a gas, the manometer reads as shown in figure number B. Clear? It is also given the liquid used in this manometer, we have a mercury, and atmospheric pressure is given by 76 centimeter of mercury. Fine. Give the absolute and the gauge pressure of a gas in an enclosure for A and B. Now listen carefully. From here you can see, if you consider here these points, let's suppose this is point and let's suppose this is another point, and both are at the same level. So definitely we can say here at point 1 we have a more pressure compared to point we can say at this point. Clear? And you know very well we can say pressure at 1 and 2 it should be same. Clear? So first if I am saying here what is this 20 centimeter, so I can say this is pressure head, yes or no? Or we can say if I am talking about number 1 gauge pressure in case number 1. Clear? So if I am talking about gauge pressure in case number 1, directly I can say this is 20 centimeter of mercury. Clear? So this value we have plus 20 centimeter of mercury. But what about absolute pressure? Clear? We have to find absolute pressure in terms of centimeter of mercury. So I can say absolute pressure I can say atmospheric pressure we have 76 centimeter of mercury and gauge pressure we have 20 centimeter of mercury. So I can write like this: 76 plus 20, and we can say this is equal to 96 centimeter of mercury. Clear to you? 96 centimeter of mercury. Clear? So now dear student, if we see part number B, in part number B it is given how would the level changes in case number B if 13.6 centimeter of water are filled into the right limb of the manometer. Clear? So now I can say here, let's suppose if I fill, just a minute. Yes. Now let's suppose if I am filling here some water. Clear? And in this question it is given the height of this water column we have 13.6 centimeter. Clear? So what is the height of this mercury column that is increases in a left limb? Clear? So now we can say actually first of all we have to convert the height of water column into mercury column. It means I can write like this: rho mercury G, and I can say H mercury. This is given by rho water G, and I can say this is H water. Clear? So we can say G and G, this one is cancelled out. Clear? So density of a water I am writing in a terms of specific gravity, or you can also write like this is 1000. Clear? Height of a mercury column, this is our objective first. So I am saying this is Hg, this is equal to density of a water. So density of a water we know this is 1 into I can say 1000 multiply height of a water column, this is given 13.6 centimeter. So from here you can say this one and this one cancelled out. Clear? This 13.6, this is also cancelled out. So I can say we can write like this: height of a mercury column, this is given by 1 centimeter. It means what is the meaning of this particular result? Meaning is very simple. If we are filling 13.6 centimeter of water in a right side, at that time the mercury level in a left limb, it will increase it by 1 centimeter. Clear? And finally we can say this one we have 1 centimeter, and total height of, or we can say total height of mercury in a left limb we will find 19 centimeter. Clear? So what is our objective in this question? Our objective is very clear, that the level of mercury that is changes by 1 centimeter amount, and total level we will find, or total height of mercury column in left limb we will find 19 centimeter. Clear? So this is all about this question. Now dear student, we are going to discuss question number 10.23, and in this question it is given to you two vessels have the same base area but different shape. Clear? So first of all I am drawing here, let's suppose this is a container, or we can say let's suppose this is a vessel. Clear? Let's suppose I am taking here this is a vessel. Clear? This vessel is given to you. Two vessels have same base area. I mean we can say this one we have base area, this is same. Clear? And we are having, let's suppose we are also having one more container, and this container is also having same base area. Clear to you? Yes. So two vessels have same base area but different shape. The first vessel takes twice the volume of water that the second vessel required to fill a particular common height. Clear? So now we can see, let's suppose if I am taking here, this vessel is filled up to this level, this vessel is also filled up to this level. Clear? And both are having same height. So I can say this value we have, that is H, same. Clear? So in this question it is given to you, is the force exerted by water on the base of a vessel the same in the two cases? Yes. Now first of all listen carefully. We can say height of a liquid column is same. Clear? And we can say here base area is also same. Clear? So first I can say pressure exerted at the bottom, this is given by rho gh. If we are taking same liquid, if we are taking same common height or same height, at the time we can say pressure exerted in a container number 1 or container number 2 in at the base, that is same. Clear? So I can say directly we can say P1 equal to P2 at the base. Clear? So if I am talking about force, so force exerted, this is given by pressure multiply area. Clear? Because both are having same base area, so directly I can say F1 this is equal to F2. Clear? It means in both situation we can say force exerted on base, that is same. Clear? Now if I am talking about part number 2, it is given in a question, why do the vessel filled with water to the same height give different reading on a weighing scale? Clear? Now listen carefully. Actually, if we are talking about weighing scale actually provides you, this is mg, clear. Now it is given to you mass. Mass is actually defined as density multiplied with volume, clear. So I can say density. In both container we have water, so I am saying density is same, clear. If I am talking about volume of water in a container, and this is G, clear. Now in this question it is given volume of a water is 2 times compared to container number 2. It means I can say volume 1 is greater than volume 2. So definitely I can say here value of weighing scale, it will be more for a container number 1 compared to container number 2, clear. It means I can say value of weighing scale for the container number 1 is greater than 2, clear. So this is all about this question, clear. Now dear student, we are going to discuss this question number 10.24, and in this question it is given to you, during blood transfusion the needle is inserted in a vein where gauge pressure is given 2000 Pascal. Okay, fine. At what height must the blood container be placed so that blood may just enter the vein, clear. So directly this is a very simple question you have. Actually this is a practical question. Let's suppose you have a syringe, you are actually inserting that syringe in your vein, and let's suppose you are transfusing blood through the needle in your vein, clear. So definitely the pressure that is outside, it will be definitely more compared to pressure inside. It means the value of gauge pressure is directly given to you 2000 Pascal. So we can see this question becomes very easy. I can write like this, P, this is equal to rho g h, clear. Now what is my objective? My objective here is to calculate this height, clear to you. So how can we calculate? Directly we can see h, this is given by P by rho g, clear. Directly we can say, now this is a gauge pressure, I can say this is 2000 divided by, now if I am talking about density, clear. So what is value of density we have? Density value you can say density of blood is actually 1.06, clear. Yes, actually relative density of a blood, you should keep in your mind, relative density of a blood, this is 1.06, clear. So now I can write here density of a blood, this is given by 1.6 into 10 to the power 3, clear to you. And what about G? I am taking this G, this one, from here this one is cancelled out, clear. So we can write like this, 2 divided by 10.6, clear. So now if you take approximately equal to 10, so you can say this is 0.2, or approximately we can say 0.1996, clear. So this is value of height of that bottle you can place, so that this blood from outside it just enter in your vein, clear. So this is a very simple question. Yes, definitely you should know about this value, but don't bother about it, because in every question if any data is required, definitely it will be provided to you by exam authority, clear. So this is all about this question, clear to you. Now dear student, we are going to discuss question number 10.25, and in this question it is given to you, in deriving Bernoulli equation we equated the work done on the fluid in the tube to its change in potential and kinetic energy, clear. So actually we know Bernoulli equation is based on principle of conservation of energy, clear. And whenever we are deriving expression of a Bernoulli equation, actually at that time we equate the work done on the fluid, that is equal to change in kinetic energy plus change in potential energy, clear. But here we are taking a very important assumption that Bernoulli equation is applicable only for ideal fluid, clear. And ideal fluid is always having non-viscous in nature, clear, or we can say that is irrotational and always having steady flow, clear. But in this question it is given, let's suppose we are assuming the dissipative force are present. It means now we can see that there are dissipative force, means friction is present. Let's suppose we have a pipe and through which the liquid is actually flowing, clear. So whenever we are talking about pipe, so if we are talking about surface of that pipe, that surface is rough, clear, and due to which definitely some amount of pressure energy that is decreases, clear. It means we can say as we are moving, as the length of a pipe is increasing, at that time pressure energy that is related to fluid decreases, clear. So what will happen if we are talking about dissipative force? If dissipative force are present, pressure energy always decreases along length of a tube, clear to you. Yes. Now if I am talking about part number B, do the dissipative force become more important as fluid velocity increases? Yes, because as velocity increases, listen carefully, as velocity increases, it is a more tendency to become a flow turbulent, clear? As well as more is the velocity we have, definitely viscous force that is acting, that will be more, clear? It means definitely we can say if velocity is more, dissipative forces will be more, and more decrease in pressure energy we will find, clear? So this is all about this question. Now students, we are going to discuss question number 10.26, and actually this question contains here two parts, part number A and part number B. In this question it is given to you, part number A, what is largest average velocity of a blood flow in an artery of radius 2 into 10 to the power minus 3 meter if a flow must remain laminar, clear? So actually we have two types of a flow, laminar flow and turbulent flow. Laminar flow is actually related to streamline flow or steady flow, clear? And if we are talking about turbulent flow, so turbulent flow is a zigzag motion of a fluid molecules, clear? So definitely how can we decide a flow is a laminar or turbulent? It is given by a number, that number is actually Reynolds number, clear? So now we can see here, you can see if we are talking about Reynolds number, the Reynolds number is given by Re, this is equal to rho Vd by neta, clear? And the most important part, what I am saying to you, if you observe this Reynolds number in NCERT, this part is now is not available, clear? But question is given to you in end exercise, so you should know this formula. Reynolds number is given by rho Vd by neta, clear? And my objective here is to calculate V, velocity. So I can say this is neta, Reynolds number divided by this is rho, and I can say here this is diameter d, clear? Now it is given to you viscosity of a blood, this is 2.084 into 10 to the power minus 3, clear? And it is multiplied with, I can say, Reynolds number. So because it is given, this flow, it must remain laminar. So actually if we are getting Reynolds number less than or equal to 2000, we can say flow is a laminar. 2000 to 3000 we have a transition state, and above 3000 we can see we have turbulent flow, clear? So I am writing here Reynolds number value, this is equal to 2000 divided by density, clear? If I am talking about density, because this is a blood, clear? So what is density of a blood, you know? Yes, actually we know here density of a blood, this is given by it is having relative density 1.06 into 10 to the power 3, clear? And what about diameter? If I am talking about diameter, it is given, radius is given to you, clear? So how can we write here diameter? This is 2 times of radius, clear? So 2 into 2 into 10 to the power minus 3, clear? We can say this one and this one cancelled out, clear? 1, 2, 3 and this one, this is also cancelled. So from here we can say this is 2.084 divide 1.06 into this one and this one cancelled, 1 by 2, clear? So from here you can write like this, 1.042 divide by 1.06, clear? Approximately you are getting this value 1 but slightly less than 1, clear to you? So now we can see approximately I am saying this value we have 0. Let's suppose I am writing like 0.98 meter per second, you can calculate, clear? Approximately this is equal to 1 but denominator is more, it means definitely this value is near about 0.9, clear? So this is all about velocity of average velocity of that blood flow, clear? Now this is about part number A, but if I am talking about part number B, in this question it is asking to you what is corresponding flow rate, clear? So corresponding flow rate, this is given by area multiply velocity, clear? So area multiply velocity, area is given to you, this is we can say pi r square multiply velocity, clear? Pi, we can say this is 22 by 7 into radius is given to you 2 into 10 to the power minus 3, 2 into 10 to the power minus 3 whole square. And what about velocity, clear? So velocity we have already calculated 0.98, clear to you? So from here if you calculate, we can say 22 by 7 into 4 into 10 to the power minus 6 into 98 by 100, clear? So from here we can say this we are getting 114, clear. So this is equal to 22 multiply 4 into 10 to the power minus 8 multiply 14, clear. So from here I can write like this, 22 into 56 into 10 to the power minus 8, clear. And because we are talking about flow rate, clear, flow rate means we can say volume of blood that is flowing per second, clear. It means I can write like this is in a meter cube per second, clear. If you multiply 22 multiply 56, definitely you can get here value of flow rate, clear to you. So like this you can calculate this question, clear, or you can solve, clear. So this is all about this question. Now dear student, we are going to discuss question number 10.27, and in this question it is given to you a plane is in level flight at constant speed, okay, and each of its two wings have an area of 25 meter square. It means area of a wing, this is given to you 25 meter square. If speed of air is 180 km per hour over lower wing, okay, and 234 km per hour over the upper wing surface. So let's suppose I am assuming, let's suppose this is a plane and here we have velocity, this is 234 km per hour, clear. We can convert into meter per second. So we can say this one is, we have 5 left, so we can say this is 3 and we are getting 65 meter per second, clear. If I am talking about lower V2 value is given to you 180 km per hour, I can say this is 5 by 18 and this one we have 50 meter per second, clear to you. Now it is given a plane, this one is clear to you. Now our objective in this question is to calculate plane mass, clear. So for plane mass, first directly you can say whenever you find such a situation, definitely you can say we can apply Bernoulli equation, clear. So Bernoulli equation we can write like this, P1 plus 1 by 2 rho V1 square, this should be equal to P2 plus 1 by 2 rho V2 square, clear to you. Now P1, so we are writing here P1 minus P2, this should be equal to, clear, or you can also write like the P2 minus P1, this should be equal to 1 by 2 rho V1 square minus V2 square. So from here we can say 1 by 2 into density of air we are taking, that is 1, so 1 multiply V1 square, it means I can say 65 square minus 50 square, clear to you. Now we can write like this, P2 minus P1, clear. So P2 minus P1, this is equal to 1 by 2 multiply, I can write here A square minus B square, so this is equal to A minus B, A plus B, clear. So A minus B, 65 minus 50 and this is 65 plus 50, clear to you. So from here I can see this is 1 by 2 into 15 into 5 and this is 1 1, clear, 5 and 1 1. So from here we can see, we can write like this, 15 by 2 into 115 Newton per meter square, clear. Now can we calculate here net force acting? Yes, net force we can say this is P1 minus P2 and I can say here we can multiply it with total area, clear. Now actually here we have two wings and each is having each of two wings is having area 25. So what is total area? That is 50 meter square. So I can write like this, 15 by 2 into 115 into 50, clear. From here you can see this is 25, clear. So 15 multiply 25, you can say this is 5, we have 7, so 375 into 115 Newton, clear. What is my objective? My objective is very clear, is to calculate value of mass of a plane, clear. So mass of a plane, this is given by yes. So now if I am talking about mass of a plane, clear. So mass of a plane, this is given by, I can say net force, clear. One more term is given to you in this question, we have a level flight. Level flight means we can say this flight is in equilibrium position at this point. It means we can say at this position mg force is acting in downward direction and we can say upward force is acting in net upward force is also acting. It means this net upward force that is acting, this is balancing this mg, clear. So now I can write this is equal to mg, clear, and this value we have equal to 375 into 115, clear. So I can see mass, this is given by 375 into 115 divided by 10, clear. So now if I multiply 375 and 115, clear. So now we can write like this, this is 5, we have 2, so 7 we have 3, and this is 18, clear. 5 7 3 multiply 5 7 3, clear. So we can write like this 5, this is 12, we have 1, so 9 7 16, 16 or 5 21, we have 2, 2 1 3 3 6, and we can say this is 13 and we have 4, clear. So from here we can say this is 4 3 1 2 5 divided by 10, clear. So from here we are getting mass of a plane, this one 43125 kilogram, clear to you. So this is all about this question, clear. Now dear student, we are going to discuss question number 10.28, and in this question it is given to you, in Millikan oil drop experiment, what is terminal speed of an uncharged drop of radius and density, that is one, clear. So value that is given to you, we have radius r and value is given 2 into 10 to the power minus 5 meter, clear, and density rho, this is given to you 1.2 into 10 to the power 3 kilogram, clear to everyone. Yes. Now take the viscosity of air at the temperature of experiment is to be this one, clear. So I am taking this viscosity 1.8 into 10 to the power minus 5 Pascal second, clear. So this is value we have. Now our objective here is to calculate first terminal velocity, clear, terminal speed. So actually we know formula of terminal speed, this is given by 2 by neta 2 by 9, clear, r square divided by neta sigma minus rho multiplied with g, clear. This is a formula for related to terminal velocity, clear. Now in this question one point is given to you, neglect buoyancy of a drop, neglect buoyancy of a drop due to air, clear. So I can write like this, Vt, this one is given by 2 by 9 r square divided by neta, and I can say this is sigma g, clear. Sigma is what? We can say sigma is the density of oil drop, clear. So now I am writing like this, this is 2 by 9 multiply r square. So r, value of r that is given to you this one, so 2 into 10 to the power minus 5 whole square divided by, now viscosity 1.8 into 10 to the power minus 5 multiply density, clear. So density is given 1.2 into 10 to the power 3 and multiplied with 10, clear. So from here if you calculate you can get your answer 2 by 9 into 4 into this is 10 to the power minus 10 and this is cancelled by this one, clear. I can say this is 1.8 into 1.2 into 10 to the power 4, clear. So from here you can say here we are getting only 10 and I am writing this 10 here, clear. So finally value of Vt we are getting, listen carefully, 2 multiply 4, clear, we have 8 and we can say 8 multiply 1.2, clear, 9 multiply 1.8 and multiplied with 10, clear. So from here you can say this decimal and decimal cancelled out, this is 3, this is 2, clear. I can say this one is 5, clear. So we can write like this, Vt value is given 8 divided by 27 or okay 15 multiply 9, 15 multiply 9 we have 135, clear. So value of Vt I am writing this is 8 upon 135, this is meter per second, clear to you. So like this we can calculate here time value of terminal velocity, clear. Or you can also say if we calculate here 13 multiply 5 we have 65, 13 multiply 6 we have that is 6, so we can say 78, clear. So approximately we are getting this value, this is equal to 0. Near about 0.58, clear. So I can say actually if you write here this value in centimeter per second you will get 5.8 centimeter per second, clear to you. So this is a value of terminal velocity of this Millikan oil drop, clear. Now our next objective in this question is to calculate viscous force, clear. So how can we calculate here viscous force? Yes. How can we calculate viscous force? Yes. So if I am talking about viscous force, this is given by one formula that is known as Stokes law, 6 pi neta r v. Clear? So we can say 6 into, this is 22 by 7 into neta. Neta means we can say viscosity. This is 1.8 into 10 to the power minus 5 multiply. If I am talking about radius, radius is given 2 into 10 to the power minus 5. And what about velocity? Clear? So velocity means actually here we have terminal velocity. So we can say this is you can say 5.8 centimeter per second. So 5.8 into 10 to the power minus 2. Clear? Now we have to just calculate a very simple calculation we have. Directly we can say this is 12 multiply 22 by 7 into 1.8 into 10 to the power minus 12, and this is multiplied with 5.8. Clear? So now if you multiply it, clear, definitely you can get here value of we can say that is viscous force, yes or no, or you can directly you can take approximate result. Clear? So approximately you can say this is 0.8. Clear? And if you multiply it with 12, 22, 1.8, 0.8, you will get here value of viscous force. Directly I am saying here this value, this is 3.3 into 10 to the power minus 10 you will get. Clear? Near about you will get this value. Clear? Just a calculation, very simple calculation we have. So this is all about this question. Now dear student, we are going to discuss question number 10.29, and in this question it is given to you, mercury has an angle of contact equal to 140 degree with soda lime glass. Clear? So I can say value of theta, this is given to you 140 degree. Clear to you? Now in this question it is given a narrow tube of radius r equal to 1 mm. So value r, this is given to you 1 mm. Clear? Made of this glass is dipped in a trough containing mercury. Fine. By what amount does the mercury dip down in the tube relative to liquid surface outside? Clear? So actually we know capillary rise or depletion, that formula we know, this is given by 2s cos theta upon rho g r. Clear to you? So from here we can say value of h, value of h is given by 2 multiply s. Clear? S means we can say here surface tension. Surface tension is given by 0.465, 0.465. Clear? I can say we are getting this value cos of 140 divided by rho g r. Clear? Rho means I can say density. Density of mercury we have 13.6 into 10 to the power 3. Clear? Multiplied g multiply r. G value I am taking, this is 10. Clear? And r is given to you, this is 1 mm. Clear? So I can write like this, this is 10 to the power minus 3. Clear? If you put here all the values, clear, I can write like this, h equal to 2 multiply 0.465 multiply cos of 140. Clear? Cos 140 value we have minus 0.7660. Clear? Minus 0.7660, and it is divided by this one 13.6 into 10. Clear? So from here we can say value of h, this is given by, if you multiply you can say we have 10, we have 1, 13, we have 1, 9. Clear? And it is divided by 136, and this is minus 0.7660. So directly you can calculate. Clear? And I am saying you here value of h we are getting, this value we have minus 5.34 into 10 to the power minus 3 meter. Clear? This value you will get. Clear? So now we can say value of h we are getting 5.34 mm. Clear? So my dear student, this value is indicating to you what? Clear? This value is indicating to you that this minus is indicating that now we are having level of mercury in a capillary tube that is below the outside level of a mercury. Clear? It means I can say here we have depression of this mercury level. Clear to you? So this is all about this question. Clear? Now dear student, we are going to discuss question number 10.30, and in this question it is given to you two narrow boards of diameter 3 mm and 6 mm are joined together to form a U tube open at both ends. Okay, fine. If U tube contains water, what is difference in a level in the two limbs of a tube? Clear? So actually we have to apply here a formula, that is capillary rise. Clear? So directly I can see difference we have to find. I can say this is H1 minus H2. Clear? I can say this is 2s cos of theta upon rho. So we can say rho g r1 minus I can say 2s cos of theta over rho g r2. Clear? Now we can say here we have water, so directly I can say we can write like this, 2s cos of theta divided by rho g, this is 1 upon r1 minus 1 upon r2. Clear? And this is a value of delta h. Clear? So now we can write like this delta h. Clear? 2s cos theta, s value it is given to you this one, surface tension. Clear? So we can say 2 into 7.3 into 10 to the power minus 2. Clear? Multiplied with angle of contact, this is given to you 0, so I can take this is 0, 1 upon r1. r1 is given to you, here we have diameter 3 mm, so I can say this is 3 by 2, so 10 to the power minus 3 minus, it is given here 6 mm, so 6 mm means I can say 1 upon 3 into 10 to the power minus 3. Clear? Okay. Now this is divided by rho g. Clear? So density is given to you 10 to the power 3 multiply g. I am taking g value 9.8. Clear? So from here we can see value of delta h, this is given by we can say this is 14.6 multiply, I can say this is 14.6 multiply, so 14.6 multiply 10 to the power minus 2 divided by 10 to the power 3 and multiply 9.8. Clear? Now if I am taking here LCM, I can say this is 1 upon 3 into 10 to the power minus 3. Clear? So from here you can see this one and this one cancelled out. Clear? So we can see here we have 100 only. Clear? So if we calculate it, yes, now if I calculate it, I can see value of delta h, this is given by 14.6 divided by 9.8 into 100 multiply 3. Clear? So now if I solve it, directly we can see approximately I can say 14 and this is 9.8, so we can say this is 7. Clear? But important part we have here, this is 0.7. Clear? 0.7. Clear? And it is multiplied with 100, this is 70 and multiplied with 3. So I can say this is 210. Clear? So now we can say, let's suppose we have value 1 upon 2, this is 0.5, but here we have 1 upon approximately 200. So I am taking it like this, minus 2 meter. Clear? So I can say this is 0.5 into 10 to the power minus 2 meter, or I can say approximately this is equal to 0.5 centimeter. Clear? So this is a difference in a level of water in two limbs of a U tube. Clear? So this is the answer. Clear? So this is all about this question. So dear student, this is all about we can say this is end exercise solutions of chapter number 10, mechanical properties of fluids. Hope you enjoyed this session, and definitely here you will find some key concept as well as these questions will be helpful to you to understand the theory part of this chapter. Clear? So this is all about this session. Thank you so much.